Today we're going to do a video all about breadboards. So what is a breadboard? Well, broadly speaking, it's a device which allows you to prototype or build an electronic circuit either before it goes into some level of production, or it can be simply just something that you want to build quickly and easily to test an idea that you've got. So what are we going to cover in the video? Well, first I'm going to explain what a breadboard is and how you can use it and what its limitations are. Then I'm going to give you some tips, tricks and pitfalls so that you can take advantage of those and avoid the common pitfalls of using breadboards so that you don't have to fall into them. But breadboards didn't just magically appear all of a sudden. There was an evolution and it spanned over 100 years. So before we get into the main core of the video, I'm going to do a short clip on the evolution of the devices used to prototype electronic circuits by hundreds of millions of people in the world, well over a century. And I promise you it won't take long and it's worth watching. However, if you already know all of this stuff, then you can skip to the next chapter. Otherwise, make yourself comfortable and I will take you through it. You might be surprised, especially if you're a younger viewer. If you do find these videos useful or entertaining, please do subscribe so that you don't miss new videos from me. It's absolutely free and I promise if you do, I will keep producing more videos for you. So what you see in front of you now is a turret board. These were commonly used in electronic manufacturing for the first half of the 20th century. They were also used in military electronics during World War II and also used in applications like audio equipment, guitar amplifiers and power supplies, etc. Their popularity reduced with the rise of breadboards and printed circuit boards later on, which also allowed for quicker and cheaper manufacturing. So turret boards are still used today in some applications, and actually the fact that they're point-to-point wiring is particularly good with high frequencies or high power dissipation. So that covers that. So breadboards for bread. So they were from around about 1920s to the 1940s, and that's when that was most popular. And as the name suggests, the original breadboard, the OG of breadboards, was the board that bread used to sit on in the kitchen waiting to have slices cut off it, and thus protected the kitchen worktop from knife cuts. Now, at some point, some eagle-eyed budding engineer or enthusiast might have said to themselves, what I need is something that I can put components on that's made of wood, I can put nails in just like the turret board but less expensive, and then wandered into a kitchen at home and said, hey, that's just what I need, it's a breadboard. I've got no idea whether this actually happened, but it wouldn't surprise me if it did, and I wonder how many arguments might have resulted from a stealthily removed breadboard. Now, these were mainly used by hobbyists and engineers to build prototypes, and they, as I said, would bang nails into the breadboard, mount components by either wrapping the leads around them or the wires to them, or soldering them, possibly, onto the nails to complete the project. So that's how the humble breadboard name came about. They were actual OG breadboards. So in the 60s and the 70s, the solderless breadboards came out. They were an idea that somebody came up with. It'd be really good if you just push a wire into a hole. The very early ones in the 60s were sprung loaded, I believe. But as the sort of 60s progressed towards the 70s, plastic injection molding became a little bit more precision and suitable for higher yield manufacturing, and it was possible to create the first set of solderless breadboards visually similar to what we have today. Here is a picture of the Enel L83 breadboard, which I believe was a cheaper economy version of the more expensive earlier models from the 60s. And the earlier models, they were fully loaded, some of them, and they had signal generators, amp meters, voltmeters, loads of switches, loads of stuff on them. But they did command a high price, which would have been equivalent to possibly maybe £8,000 in today's money. Bringing this up to date with modern day breadboards, they've evolved in a few ways. I mean, injection molding and manufacturing has become even better now, depending on where you buy it and who it is that makes it. I mean, for example, they've now become modular, so as you can see there are some tags on the board, which means you can clip them to other boards, and you can make an array of breadboards into a large project if you really wanted. Although it might be nice to look at a large project, they're not really practical in many cases other than for educational use. However, having breadboards available to you to do experimentation is a fantastic asset to have. And it won't go away, we'll always be doing it, I think. We're going to take a look now at what makes a breadboard good quality or not so good quality. But I thought the best thing for me to do was to go and buy the worst breadboard I could find on Amazon. And if we have a look at the front of the board, we'll find that it's got some lettering on the side which is very slightly faded, which is not a great sign. These look okay along here, and these don't look too bad either, and they're in line. So the numbers are okay, the letters are okay, apart from that being slightly faded up that end, but that could be something to do with the camera lighting. If you look down the holes, you should be able to see the opening of the sprung connector that you push the leads through. That's what we're looking for. If they look blocked, then you may not be able to get your cable in there. I would say 15, third one down doesn't look very good to me. So let me poke something in it. Well, that's weird. Look at that. I can just pick that up and the board just drops off it. So that's telling me straight away that there's something wrong. I don't think it's positioned very well. Whereas if I pick one that I don't see anything in, let's try that one. I can pick the board up, literally pick it up, but it does pull out, so it's not snagging or anything. So there's something that you need to look for. Up here on the power rails, let's see what that one looks like. That's okay. I can lift it up and it's got some tension on it. What about these down there? Let's try that one. That seems to be okay. So if you can see the jaws of the connector, for example over here, these should be okay. Oh, it does pull up. There's a little bit of resistance putting it in, but not massively. So let's have a look at a connector. So we're going to look at the elasticity of the connector. So that's probably, I would say, almost around what you'd expect the wire to be at a circumference of. But even pushing that down, it's very difficult to actually fit that in there. You can see there's a bit of distortion there. There's a bit of distortion on the left hand side. And if I give it just a very slight, I've got to push that in. If I give it a very slight bend over to the right hand side, or to the up actually, just a little bit, what happens? Well, that's definitely distorted it, hasn't it? So it doesn't take much at all. Really, there should be a bit more elasticity in that metal. It should be better than that. But it's still just about gripping it. So I give it some more, just a little bit more, just a little bit. Right, what happens now? That is definitely open now, and it virtually it doesn't slip off exactly, but there's no weight on this connector. As soon as you put some weight on, that's gone. So that's one thing to check for, is to see how elastic those are and how well they spring back. I mean, these are cheap, and it has got a bad rating, so we're kind of expecting this. Really. There's another one which is still virgin in as much as I've not put any wires into it yet. It's quite loose still though. I expected it to be a bit better than that. And I'll just give it some sideways waggling, but not much, just a little bit. And you can see it's already starting to deform. So I would say that's probably a low quality one. But even before we put anything down there, it's for sure that this breadboard has got problems on it. So let's have a look at something else. Let's have a look at an old one. Find a piece of cable and I'll chop it. I'll cut this to about 1/3 of an inch, which is the maximum depth, I think, and we'll just start sticking it in places. Let me go for 20 there. I'll push it in, I'll pull it out, I'll push it in, I'll pull it out. And 20 looks just as good as it looked before, so I would say that's pretty good. And let's just randomly push it into sockets. So you make sure that there's no obstruction to you. It's not failing to go in because the clip has been put in sideways slightly, or it's bent or buckled, whatever. And in every case, I should be able to pull the board up, suspend the board. That's how much grip should be. Now, the tolerance on these holes, from reading quite a lot about it now, is between 0.4 of a millimetre and 0.6 of a millimetre. I use standard AWG 22 gauge. Now that is slightly over the 0.6. It's about 0.64 or 0.638 or something like that. But through several years of using breadboards, I've never had any problem, and they've been used multiple projects. The breadboards that I will use are £10 a piece, and I've got good ratings, so always check the ratings, always go for good ratings. Alright, so let's just talk a little bit about how to wire things up. I know most of you will be able to do that, but some of you may not. If you don't want to watch this, you can skip to the next chapter, but you might learn a few tips along the way. So before we actually get onto the wiring, just to point out something that you may find if you buy a breadboard, some of them will have discontinued power rails. So you can see this red line comes along, it breaks, and then it continues. It's the same on all four. What that means is you've got a strip here and another strip there, but they're not connected, and you have to bridge those. So just be aware of that. If you want your power lines to be continuous, which I do, check out the photograph and don't make the same mistake that I did and buy one with this in, because you have to bridge it. I mean, it's not the end of the world, but it's something that you didn't need to do. So let's talk about wiring. Breadboards are generally 0.1 of an inch pitch, and that enables us to do things like this, is to put a chip in. All chips, all standard chips like this, are all 0.1 of an inch between the pins, so it fits perfectly into a breadboard. There are some more obscure breadboards that are not 2.54 millimeters, which is a tenth of an inch, but 2.0 or 2.25. If that happens, you won't be able to fit one of these in. You might be lucky and get a 4-pin in, or an 8-pin rather, but you will not get a long one in there because the pitch won't allow it. If you've ordered one from a supplier and they have a returns policy and it's the wrong pitch, it's not 0.1 of an inch or 2.54 millimeters, then send it back because it's not going to be any use to you really. In order to do wiring, we need some wire. So this is something I just recently bought, a couple of weeks ago actually. Haven't really used much of it at all. It's got these little wire reels inside of 22 gauge AWG, and it's got a nice little dispenser so you can put it out the holes, and it's even got a little measuring thing so you can measure how long a piece of wire is. But we don't really need that because we've got the holes in the breadboard, and we've also got the numbering system there, which on this one, which is about 2 years old, is a little bit faded now. So we need wire, we need some long nose pliers, we need some wire strippers, and then we need some wire cutters. You can do without this, you can get some cheap wire cutters. I prefer these and that's what I use. I don't know what the pin out on this chip is in terms of the power connections, but I'm just going to make an erroneous probably assumption that this one here is going to be VCC, so that's going to be plus volts, and this one there is going to go to ground, and by ground I mean the blue line, 0 volts. So we would normally use red and black, red to go to positive, black to go to the 0 volt line. So that's what we're going to do. Now you could either use the holes to measure how long it will be, and let's just do an experiment. We can take a look at that and say, right, well, I'm going to start off here on this pin for my positive voltage, and I'm going to try and go to this hole, but I don't know what that is because I haven't got a hole in the middle. So how can I measure it? Well, if we just take a look in millimeters, you should find it's 5 millimeters if it was double what the hole size is, and it's pretty much about 5 millimeters. So we can assume in that case that there's an invisible hole there. Okay, when we go across the gully, we've also got a gap, but it's not quite one hole. it's just a little bit longer. So there's about another millimetre in there. So you can't really count that as one hole, or if you do, you need to add on another, at least 1 more millimetre if you're using that spacing as being 2 holes. So just remember to add on about another millimetre. So I just wanted to point that one out. I don't normally do this by measuring it. So let's get at least one of these in, right? So let's start with the plus voltage. So the way to do it, in actual fact, I do it, is this way. So I come up here and I just, by trial and error, I know I need 8 millimeters there. I'll just pull that down so that's up to about 8 millimeters. I'll bend that over, I'll bend that over. I'll cut that there. That should go directly in without any problems. And that's how we do it. So cut further. You need to cut just over an inch, about 26 millimeters down the insulation. We'll do the black one now. So it's about there. Pull it off. About another 8 millimeters there. Put that up to 8 millimeters there. Just to eyeball it. And then do that. And do that. Flip this round. And we're going from there to there. And it's all done. It's so simple to do. If you use that method, you won't go far wrong, I promise you. So the next thing would be, what about wires in between pins? So from this pin here, say on, what was it, 50, somewhere else on the board. Well, it might actually be going back onto the same chip. Who knows? So let's try that. That's where it becomes a little bit more tricky. So you want to connect to that pin, and that's the first available pin, so you should use that. The reason that you should use that is you may want to use these holes for other connections to that pin, so you should start from the outside and work in until there's no more holes left. So let's use a wire, white wire, and we'll go from 50 to 10 because that's directly opposite. What I do is do it by eye. What I'm going to do is I'm going to start at the top. So I'm going to take my 8 millimeters and lob it right off there, and I'm going to stick it straight into there. I'm going to lay it down, I'm going to put my nail there, and I'm just going to bend it around here. Do the same thing down here. Bend it further than it needs to go. Bring it down to here, which is the next place I'm going to need to go. Bend it there. And bend it there. Now I'm going to put a little nick in there. And I'm going to give it a cut at 8 millimeters. That might be slightly long. That is slightly long. But we're already aligned. We're nicely aligned, and it's not exactly a right angle there, but we can make it one if we really need to be pedantic about it, and that will align quite nicely there. It has to go over that link, but you know. So that's fairly neat, and that's the kind of method that I would use to do the wiring. Some people may have other methods, but I find that has worked for me. So what else is there to tell you about the board? Well, you've got some of these tags on the side, and when they fit into another one of these, they go into these holes. Of course, underneath you've got this yellow sticky, which you can peel off. This is super sticky stuff, which is in fact quite useful for getting the white stuff that's coming off these breadboards. So don't start using it as a clothes brush. So what if your connectors that you're going to put in there, or your wires that you're going to put in the breadboard, are too thin? So we have here, sitting on the side, these tiny little 15 picofarad capacitors, and they're skinny little legs. They hardly, that won't lift the breadboard up. Look at that. A very, very poor connection. Like a worm in a bucket, just slips right out. So that's not going to be very good connection. So what do we do about that? How do we get that into the board? Well, there's a couple of things you can do. You can either strip back some wire like that, and you can pre-solder that in, or you can wrap the wires around it, whichever is most suitable for you. That's one way of doing it. Or you can buy some intermediate connectors, like a transistor connector, for example, a TO92. You can go and check it out. And they're little connectors that will sit in the board with the right diameter leg quite snugly, but it will also allow you to put the thinner transistor legs in, or capacitor legs. If you're doing some analog work, then what you can do is build it on a perf board and then put some pins in it which will plug straight onto the board. That's an alternative. In fact, the same pins as you'll find on here, which is an Arduino, they're also 2.54 pitch, and then you can put these pins into the board, and you can plug a socket directly in and plug your board in, or you can solder them into the perf board and just push the board straight in. Well, an example is this actually. So here's an example. So we've got an OLED here, and I've wired up on this connection. I've wired it up. It's not that neat, but I've wired it up so that I can just remove that and put a new one in, or put something different in there. Now, admittedly, that's not perf board, but you get the idea. Alright, so there's one or two small things I need to finish up on, and one of them is to do with parasitic capacitance. So what is parasitic capacitance? Parasitic capacitance is capacitance which resides in the infrastructure of something, like within a breadboard, for example. I've got a small capacitor here, which is a 15 picofarad capacitor. So I'm going to connect that to my LCR meter, and you see it's measuring around about 14.8 picofarads. This is quite a high resolution meter, so it's picking it up quite nicely. What I want to do is I want to put it across these two contacts, which I've got stuck into the power rail. Now the power rail's got nothing else connected to it at all, but it's still got 14.8, so that's interesting. Now if I short this out, just to make sure there's no residual charge in there or anything, that is still showing a capacitive value of 15 picofarads, which is quite high, but it's not unreasonably high. So what I'll do is I'll go between the two adjacent tracks on the vertical strips. So we go between there and there, and you can see that's gone right down to 1.9 picofarads. So although it wouldn't necessarily be a problem on the power rails, it certainly could be a problem in between those strips. Now, admittedly, that's a very, very small capacitance, but if you're dealing in high frequencies, this can make a difference. So let's try two opposing. That's even less. So I'm going across the gully now. So that's just over 0.5 of a picofarad, which is really tiny. So you can see that this exists for real on the board. And the reason that the ones on the power rail obviously are higher are because there's a lot longer on the power rail. So the plates of the capacitor, which are effectively the rails themselves, are much longer than the vertical strips. They will have a bigger value. And in fact, that one has got a higher value than the top. Now that may be because I've got other things plugged in. In fact, it is. Like when I take that out, that's dropped to 15. Yeah. So yeah, on there, then we've got roughly 15 on the top and the bottom between the tracks. On here, we've got under 2 picofarads, and between the top and the bottom, just over 0.5 of a picofarad. So capacitors can cause a delay in rise time of a signal. It might affect an oscillator and its resonance value. So if I were to design and put a Hartley oscillator on there and just plug it into this board, then I might find I'm not getting the frequency that I'd expected. Or let's say I commissioned it on a turret board and everything was working absolutely fine, and I took those same components and I put them on the breadboard and connected them up, I probably would not get the same response, and should just bear that in mind. If you have to put some analog stuff on it, probably the best thing to do is to either use a perf board like I indicated before, or to do what they call dead bug wiring. So dead bug wiring is you mount all the components upside down, preferably on a little, possibly on a little ground plane that you connect to the 0 volts, and you put some hot glue, or maybe some hot glue or some sort of stickiness on them to keep them there on an insulated ground plane. So not directly on the ground plane, but on an insulator, and try something like that, and then you can wire all the little legs together. It's not nice, but it might work. I think in general though, if you're going to do it on a breadboard, you need to do it on something else and plug that into the breadboard, so that you're not using the breadboard circuits itself to actually enact the circuit that you've designed. If, however, you're using a microcontroller dev board and you've just got it plugged in, you're probably not going to have any of these problems. If you're just using it for output and input and then using a display and stuff like that, you'd be absolutely fine. Well, I hope you enjoyed the video and you found it interesting and entertaining and useful. If you did, please like and subscribe, share with your friends. We're a small channel and trying to grow, so every little helps. That being said, I will see you next time.